1-5
No, you don't.
is all about solving equations. And we're going to look at a lot of different equations. And this is something that you've been doing since Algebra 1 or maybe even before, solving equations, right? But today we're going to look at solving all different types of equations. We're going to look at real basic ones like single step, multi-step. We're going to look at some with have parentheses in them. We'll talk about other types of equations as we go throughout the semester. Today is just going to be some basic linear functions. But then we're going to get into some that have some different solutions to them. And then we're going to get into some story problems where we can set up an equation to solve a situation. All right, so if I see one with a variable on one side, and it really doesn't matter what side that variable is on. Like I said, these should be pretty straightforward. We're just solving a two-step equation is all we're doing here, trying to get x by itself. And so here we would subtract 3, always do the opposite operation, divide by 2, x equals 2. One of the things that I love about equations, and we'll see this on a lot of things that we do throughout the semester, but is we can always check our answer. And I know sometimes we don't always take the time to do it. But I can take 2, I can plug it in for x, 2 times 2 is 4, 4 plus 3 is 7. And if I have a question like that, if I have an equation that I'm solving like on the test, then there wouldn't be any reason why I should miss something like that. Because I can always check my answer and I can verify that that answer works. We could also see ones with variables on both sides. And on some of these, there's more than one way to kind of approach it. If I see one like this, once again, we're trying to get our x's together. And so here we have a variable on each side. And so what I always like to do is move the one over that's smaller. And there might be some where we have negatives and things like that. But I would probably choose to move the 2x as opposed to the 3x, just to keep my x positive. And if I move the x's to the left, then we know we got to move our constants to the other side. So they got to get on opposite sides of one another. So over here we have x left. Over here we have 6. And we can still always check. And sometimes it's going to be harder to check than others. And we're going to get answers sometimes that are like maybe fractions or decimals. And so those would be a little bit more difficult to check as well. But sometimes, I mean, you don't even have to show me that you plugged it in and checked it, right? But just to kind of get that verification that it does work, 6 times 3 is 18. 18 minus 5 is 13. 6 times 2 is 12. 12 plus 1 is 13. Both sides equal 13. There we go, right? So highly encourage you, like on the test, why not check it, right? That tells me that I've done something right. Because it's always easy to make like a real easy mistake. And some of the mistakes I saw yesterday, even finding like slope, mistakes that were made were mostly because we missed a sign. 2 negatives make a positive, something like that. And so just missing a little sign can change our answer. Go back to this problem here. I'm going to show you this, and you've probably never seen this before. But it's easiest, I think, to do it on this one. We call this one the intersect method. And I just want to kind of show you the relationship that these things have. You could use your calculator to solve this one, okay? And we've kind of done that before but we've done it when it's like two separate equations. And so I could set this up as two different equations. I could set it up as y equals 3x minus 5, and I could set it up as y equals 2x plus 1, and I could graph it. And you could do this really for any equation. You're going to take one side of the equation, set it equal to y. You're going to take the other side of the equation, you're going to set it equal to y, and we're going to graph this. So let's graph this, and let's see what happens. And I just want to show you how you could use this to solve. And is it the best method? Maybe, maybe not. Kind of depends on what kind of numbers we have. For this one, I would say probably graphing it would not be the most ideal method. Ties in to what we did earlier. And when I plugged in 6, I got 13 on both sides. And so can you do the intersect method? Yeah. And you might see that, or they might ask you to do that, like on some of your homework problems today. If you want to use your calculator, you can do that. But in most cases, we usually just solve it by hand. But that would be something that you could do to solve an equation. Another one I wanted to show you here, and this is really just kind of a two-step equation, but we're going to see some fractions from time to time. And so on this one, it's a real basic two-step equation, but we have fractions. And there's a couple of different ways that you can kind of go about doing this one. Some people like to get rid of the fractions, okay, because they don't like dealing with fractions. Or you can leave the fractions and you can just solve a two-step equation. And so I'm going to kind of show you both ways. And if we ever end up with fractions, what would be the best way to kind of go about doing this? If I just keep them as fractions, then I'm going to add 1. So I get 7/5 plus 1. And that's something that you could probably put into your calculator as well. But 1 is really 5/5. So 7/5 plus 5/5, remember you got to have a common denominator, would really be 12/5. Okay? And like I said, you could just type it into your calculator. Especially like on the graphing ones though, you want to make sure you put that fraction in parentheses. Some of you have a fraction button on your calculators. You can just put it into that fraction. If you don't know if you have a fraction button or don't know where it's at, I can show you. And then to get this one, to get x by itself, we have two options, okay? In most cases, because this is a multiplication sign, we would say I'm going to divide by 3/4. But when I divide by a fraction, that's really the same thing as doing what? Multiplying, close. The reciprocal, yep. Multiplying by its reciprocal. So what I could really do here is I could multiply by 4/3, the reciprocal. And what that does is it makes the 3's disappear, it makes the 4's disappear. We get x by itself, okay? And just kind of remember some of your rules here for fractions. With addition, subtraction, we need a common denominator. But with multiplication, I don't. 12 times 4 is 48. 5 times 3 is 15. Okay. If you can reduce it, then we reduce it. In this case, 3 can go into both of those. And we get 16/5. Okay. Once again, I probably would prefer a fraction as opposed to a decimal. In this one, your decimal is what we call a terminating decimal, where it stops, it doesn't go on forever. So if you have a terminating decimal, that's not a bad deal. Really, it's the repeating decimals that we want to kind of stay away from, especially. Hey, I want to show you another way that you can kind of approach this. Same problem. In some ways, I kind of like this a little bit better, but you got to do a little bit of work to set it up. So right now we have fractions. And if I said, how many people love fractions? Not too many hands would probably get raised, right? So we want to get rid of the fractions. if I want to solve this without fractions and just get it into a basic old equation that we're kind of used to solving, then I need to get rid of a fraction. And so what I could do here is multiply by the least common denominator. So right now, my denominators are 4 and 5, two numbers on bottom. What is the lowest number that both 4 and 5 would go into? 20, okay? And so here's what we're going to do. We're going to multiply all parts by 20. And I know the first thing you might be thinking is, how's that going to help us, right? But I'm going to show you. And some of you might even say, well, I need my calculator to do that. But I bet you could do it without your calculator too. And you're like, there's no way, Mr. Reader, right? Well, if I take 20 times 3/4, when we first think about that, I can't do 20 times 3/4 in my head. But you can do two things here. I can either do 20 times 3 and divide it by 4, or I can do 20 divided by 4 and multiply by 3. So if I said, what's 20 divided by 4, what would we get? 5. And then 5 times 3 would be 15. So we can do that really quickly, even without our calculator, okay? Now, it's not wrong to use your calculator. I know we love our calculators, but know where those numbers come from a little bit sometimes too is helpful. Over here, 20 times 1 is just 20 because there's no denominator. And then same thing here as we did here. I could do 20 times 7 divided by 5, a little bit harder in my head, or I could do 20 divided by 5, which is 4, and 4 times 7 is 28. And now it's just a really clean two-step equation with no fractions in it, and now it would be should be a piece of cake to solve this, right? I could add 20. Notice that we get to the same point right here as we got over here, and then it's just reducing it. Okay. So I'm just trying to show you that there's a lot of different ways that we can go about these. Probably the biggest thing that you're going to see in college algebra, as opposed to, I know you've solved a lot of these and you probably even looked at the first couple of examples and said, hey, these are a piece of cake, right? Hopefully. Because we have been solving equations for a long time. But we're going to see problems that have equations that have decimals and fractions and other things in them. And so it's going to be a little bit ramped up. The solving of them, we're going to be seeing numbers that we're maybe not used to seeing. And we're going to see fractions. And so I just want to show you different ways that you can kind of approach and go about doing it. Okay. On all the ones that we have done so far, we have gotten one solution. We get like x equals 2. 2 is the only answer, only number that works for that equation. If I plug 2 in, it works. Nothing else is going to work. Well, we have some special scenarios or special solutions that could happen. The first one we're going to look at is a no solution situation. If I give you an equation, and I'm going to start off with a real basic one. Our goal is still the same. Our goal is still to solve for x. So we still want to get our x's together on the same side. And if I'm going to do that, I'm going to add 24x. So those disappear. Those disappear. And so in this case, my x's are gone. I don't have any x's. I can't solve for x anymore because my x's have disappeared. And what I have left is 7 on the left, bless you, and 17 on the right. Well, does 7 equal 17? And we know that that definitely is not true. So anytime your x's cancel out and you get two things that are not the same, we say there's no solution. There is no number I can plug into this original equation that's going to work. Nothing makes that true. Okay, the other one I'm going to show you here. And once again, this is pretty straightforward. You might see some of these that have parentheses and more steps to them, but I'm just kind of showing you some basic ones here. In this case, if I added 2x, my x's disappear. And the big difference here is your x's still disappear, but when I look at what's left over, I got a 3 on the left, a 3 on the right. Both sides are equal to each other. And that's always true, right? 3 is always equal to 3. And so what we say in this scenario is we call this infinitely many solutions. I usually refer to that as IMS. Or in Algebra 2, you might have said all reals, okay? Which would work as well. Every single number would work. Every number I want to plug in for x would work. I could plug in decimals, fractions, negatives, positives. Any number I want to plug in is going to make both sides of the equation true. So those are two special scenarios we could run into. And so don't think you've done something wrong. Every once in a while we'll run into a no solution or infinitely many solution. Okay. The other thing that we're going to look at is a couple of examples of some story problems. So I want to show you some scenarios of those. If you have your textbook out, you can, or with you, you can get it out. If not, I'll just kind of throw these up here and talk about them. Just kind of go through examples of a couple of different ones here. Okay, this one's not from your book. This one is what we call a simple interest formula. Simple interest would be something that we would use, like if you have a savings account at a bank, they're going to charge, or they're going to give you interest based on the simple interest formula. At the end of whatever time period it is, then they're going to calculate your interest. So I is your interest, P is your principal, R is your rate, T is your time. So if I said, how much interest do I earn on a CD if I put in $5,000 at 4% for 2 years? So there's a lot of different ways at banks that you can earn interest. You know, you've got money markets, you got savings accounts, you got CDs, a certificate of deposit. If you're talking more about, like, if you're taking personal finance and you're talking about like investing, that's more compound interest. This would be like a specific account where you're earning simple interest in an account. So in this case, we are trying to figure out how much interest I'm going to earn. My principal is how much I put into the account. My R is my rate. 4% though, we have to change it to a decimal. So don't put in 4, because that's it's gonna give you a really large number, but the bank's not gonna give you that much money. And then T is your time in years, which is 2. Right. And I gave you a real basic one here. I could give you the interest and the rate and the time, and we would have to figure out how much money do I have to put in to earn that much interest. And so you could put in any unknown here. But this one, we're just going to straight multiply. So if I take 5,000 times 0.04 times 2, how much interest would I make? Did you type it in? What'd you get? 400. Okay, it's not too shabby, right? For letting that money sit in there for 2 years, $400. No, it's a pretty good deal. Unfortunately, like most of your savings accounts or money markets make less than 1%. So they're not really money making scenarios at a bank. And so in order to make money like that, you'd have to do something that's a little bit more long term. Okay, so that would be one type of story problem we might see. Another one I'm going to do with you here is number 52. And this one is on page 94. Okay, this one is a perimeter problem. This will probably take us back to your geometry days. Everybody's favorite, right? Good old geometry. Not so much. So we got a couple of different things here. First of all, it's a rectangle. And so I'm kind of a visual person. I like to see. Can you do this without drawing a picture? Without a doubt, right? But I like to kind of draw a picture sometimes to kind of see what we've got and kind of label things. And so in this case, we know that we have a perimeter of 39. And when I find perimeter, what am I really finding? The outside, distance around. Be like a fence that goes around the backyard or something. The length is twice the width. So we know this is length. We know this is our width. And not only do we know that, but we actually know that the length is twice the width. Okay, and they could give me all kinds of different expressions, like the length is 8 more than the width, or all kinds of different things. But this one's pretty straightforward. The length is twice the width. And the reason why that's really important is because usually if I was going to find the perimeter here, I would go 2L plus 2W equals 39. Because I have 2 lengths, I have 2 widths, because on a rectangle, opposite sides are equal. But because we know that L is really 2W, I can take this and I can put it in where the L is. So I could go 2 times 2W plus 2W equals 39. Or some of you might even like just to say, let's just add it up. 2W plus 1W plus 2W plus 1W. You could just add up all the W's, right? But we only want to use the one variable. I can't solve this if I have an L and a W in the equation, right? So I have to rewrite L in terms of W, is what we're saying here. So this would be 4W plus 2W equals 39. So we get 6W equals 39. And my width, 39 divided by 6.
You need it in
Sure,
there? Okay. I can't do that either. 6.5.
6.5. Is it okay to get decimals?
Yes.
Yeah, we can have a length that is a decimal, right? So if my width is 6.5, what would my length be here? 13. And those would be our 2 dimensions, okay? And if you wanted to check it, you could take 13 plus 6.5 and then double it, and that should be your perimeter. You could add up all 4 sides. There's a couple different ways you could do that. Okay, so we just have to set up an equation that is kind of representing what we're given. The last one I'm going to do with you here is number 45. This is going to be a problem off your homework, so I'm not going to finish it, but I'm going to kind of help you get it set up so you kind of know how to set this one up. So it's talking about this person has 2 job offers or 2 choices. The company that they're going to work for is either going to give them a monthly salary of $4,200. Or they could work on commission and they could get a $3,600 salary, but you could get a 4% commission. You guys know what a commission is? What are people that work off commission? What? Car salesman, yep, big one, okay. A real estate agent, they work off a commission for the house how they sell. A car dealer is a big one because, and in most cases, it's if you're a really good salesman, this would probably be a better deal, right? But we want to figure out what this is asking us is what amount of sales will the two be equal? How much do I have to sell to be equal? Okay, and so this is a furniture store, and so I need to figure out how much furniture do I need to sell in this month to make this even. And if I think I can sell more than that, then I'm going to choose this one. A lot of people would just say, I just like to show up for work and get my $4,200 and be good, right? A lot of places do it different. Like some furniture stores, everybody shares the commissions, and so it's a lot of different ways that it's handled. But we want to know when are these two equal. So we're going to say 4,200 equals 3,600 plus, and kind of like we did a few minutes ago with the interest one, we're going to change 4% to 4% times X. Okay. And I want to know when are these two equal. Okay. And X would be the amount of sales that I would have to sell to make these equal. And then that would kind of help you make your decision. My first kind of introduction into a commission was my family and I went to on vacation to St. Louis one summer. And we went to the mall, and I came from like a really small town, northwest Kansas, and so we didn't go shopping a ton, But we went to this mall, and the store, the people we found out must have worked on commission because a guy had come and like found some sizes and things for us, and we didn't really know. He didn't say anything to us, but like he was really nice. He helped us out, but it was really busy that day in the store, and so there was like 3 different lines you could go check out in, and his line was pretty busy. So we went to another line, and as we're leaving, he kind of like starts bad-mouthing us, like kind of starts yelling at us a little bit. And so we just kind of ignored it a little bit, but then as we kind of started to figure out, like, he must have worked on commission. And so he probably was mad that he had helped us and we didn't go to him. And that's probably why his line was longer, because all those people were going to him because that he had helped them, but we had no idea. And he didn't tell us that. So, we had never really been in that situation. So we kind of came to figure out that, hey, that was good. But probably, it was bad on us that we didn't go to him, but it was also, maybe he should have like said, hey, by the way, I'm working on commission. If you guys would come to my line or whatever too, but I don't know. But I always remember that. That's kind of like the first introduction I had to commission and kind of how it works. Okay. I'm going to let you finish that one out. That is one of the problems on your homework assignment, but I helped you get it set up. So we got this for homework today. The first couple of problems will be pretty straightforward, and then kind of as you work through, they're going to get a little bit harder and harder as you go. Okay, and then we'll get into like multi-step. So So when we do a multi-step, we're going to have a lot of different things that are going on within this equation. But our goal, once again, is to get x by itself at the very end. And I give you one like this because one like this is missed a lot. And so what do you think would be our very first step here? Distribute, okay? And we got to distribute on both sides. And I'll tell you right now, one of the most common mistakes people want to do is they want to try to combine the 8 and the 3 together, okay? And we can't do that because this 3 is being multiplied, and we always have to do multiplication and division before we can do any addition and subtraction. So this 3 has to be distributed. So we have to distribute on both sides. Sometimes you may not have parentheses on both sides. And when I distribute here, I'm going to distribute a -3. I'm going to treat that minus sign in between there as a negative. And so then this would be -3x minus 6. Okay, and once again, just the signs are probably the thing that are going to make you miss this more than anything else. And then we're going to combine like terms. And when we get to this point, we have all kinds of different options that we can do. I could move 3x to this side, I could move 6x to this side. I usually kind of focus on my x's first. What do you think would be the better one to move? The 6x. I like the 6x just because it's going to make my x's positive. Okay. If I wanted to, I could have added 3x to each side. So your work doesn't always have to be the same as if you're looking at a friend's work and they did it a different way, but you end up with the same result, then that's okay. But you should end up with the same result. There is only one answer here. And if you look at somebody else's and they get something else, then somebody did something wrong, right? So if I move my x's to the right, that means I'm going to move my constants to the left. So we get 8 equals 3x. And we're not always going to get a nice whole number. And one thing that I'll tell you, and you've probably heard this before, but the way we would probably prefer to leave our answer here is just leave it as a fraction. Because 8/3, if it was divided, would give us a decimal, right? And that decimal is a repeating decimal. And so 8/3 would be the way I would prefer you would leave this. So it's more of an exact answer. The decimal here would be 2.6 repeating. And number one, if I was going to check this answer, I can't take 2.6 repeating and plug it back in, but I can take 8/3 and plug it in for x and see if it works. Now, this one, as far as checking it goes, it would be more difficult to check, right? Because it's a fraction. Not that you can't do it, but it's going to take a little bit more effort to check this one. And so, yeah, checking it would be good, and I think that's probably the reason why sometimes we don't check it, is because it takes a little bit more time to do it. I'm